We will explore the eye by starting with the outer layers and dissecting our way inside the eye. Throughout the video, we will provide schematic diagrams to help you visualize the salient structures.
Here we start by viewing the front of the right eye in its properly oriented position, and I've secured the eyeball at its 4 rectus muscles. The first structure that I'll point out is the cornea, which is a thick transparent layer that lies centrally on the surface of the eye and covers both the pupil and iris. Here's a cross-sectional diagram showing exactly the relationship I just mentioned, the cornea over the pupil and the colored iris. The cornea needs to be transparent to allow ample light to enter the eye and reach the retina at the back of the eye, where images of our sight are formed. Its transparency is due to irregularity in the arrangement of cells in its extracellular matrix. In terms of vision, it's the cornea that is actually the major refractive surface for incoming light, and provides the main focusing power of the eye. The lens, on the other hand, then fine-tunes that focus. Though, technically speaking, it is actually the tear film on the surface of the cornea that refracts light the most.
So I've heard that corneal abrasions are a very common eye injury. Can you tell me more about that?
Well, the cornea is covered by a very thin epithelial layer. A corneal abrasion is literally a scratch on the surface of the cornea. That epithelial layer covering the cornea is similar to a layer of skin, and by scratching it, you have abraded it off of the remaining layers of the cornea. It's actually very painful because the cornea is densely innervated by nerves from the ophthalmic branch of the trigeminal nerve, or V1. Okay, so next I will point out the white structure that entirely surrounds the cornea, called the sclera. It is a fibrous connective tissue that encases the intraocular contents. Covering the sclera is a thin, translucent epithelial layer called the conjunctiva. I will pull up a diagram that will help us better visualize these structures. This is another cross-section showing mainly the eyelids, but what I'll point out is the bulbar conjunctiva that covers the sclera that then continues and reflects off the eye onto the eyelid, where it becomes the palpebral conjunctiva.
So let me see if I understand this correctly. The conjunctiva and sclera start at the edge of the cornea here, and the conjunctiva extends over the sclera, reflects off of the sclera, and onto the inner surface of the eyelid. So this creates an epithelial barrier between the external environment and the inside of the orbit.
Yes, that's exactly right. Now let's go back to our dissection. As the cornea is punctured, we see the aqueous humor flowing out from the anterior chamber, which is the space between the cornea and the iris. Next, we are using a pair of surgical scissors to remove the cornea right around the limbus, which is the darker circle where the sclera meets the cornea. One interesting thing about the cornea is that it's avascular and contains very few immunologic cells, and these properties have made corneal transplant a highly successful procedure. The next structure that we come to is the iris, which you can see beneath the cornea. The iris is a colored ring of muscle that separates the anterior chamber from the crystalline lens. In the center of the iris is the pupil, which appears dark because it is a negative space opening into the interior of the eye. The iris's primary action is to either constrict or dilate, effectively regulating the amount of light entering the eye. As I dissect away the iris, you'll notice that the undersurface of the iris is dark, and everyone's iris, no matter what color it is, has a dark undersurface due to a pigmented epithelium. Directly behind and attached to the iris is a ciliary body, which I'm pointing out, though it's difficult to see from this angle. We will get a better view of it in a few moments. Now, I will change the direction of dissection and cut into the vitreous cavity. We should be able to see the lens, which lies directly behind the iris. Let's pause the video for a moment to look at a schematic of these structures. First, we will recap the structures we have seen so far. We have cut through the cornea at the very front of the eye and exposed the anterior chamber. We have seen the iris that lies at the back edge of the anterior chamber. Next, we will see the lens that lies directly behind the iris and pupil. It is held in place by zonules, which are fibrous strands that emanate from the ciliary body. The ciliary body forms a ring behind the iris. It is a muscle that contracts and relaxes to change the shape of the lens. The next step in the dissection will be to cut into the vitreous cavity, which you can see here on the diagram. Exposing the vitreous will help us better visualize the location of the intraocular lens, which lies just in front of the vitreous cavity. The first thing here that strikes your eye is the vitreous jelly, which is partially liquefied, leaving much of the empty space you see here at the outer edges of the eye. Alright, let's find the lens. Actually, this individual has an artificial lens. They had cataract surgery on this eye during their lifetime that replaced the natural lens. It's a pretty neat finding I wasn't expecting. This is what a typical artificial lens looks like. The circular portion of the lens is called the optic, and the two arms are called the haptics. Okay, let's explore the posterior portion of the eye now. The pale translucent layer in the back of the eye is the retina. The retina actually has two main layers. The inner layer is the neurosensory retina, which is made up of photoreceptors and other cells, which convert light into neural impulses that travel to the brain, specifically the visual cortex in the occipital lobes. The outer layer is the retinal pigmented epithelium, which forms the blood-retinal barrier and whose dark pigment absorbs light as it enters the eye. I will quickly note that the one thing we unfortunately cannot see inside this eye is the optic nerve, but it is found at the most posterior aspect of the eye. Now that the eye is cut open, we can see the ciliary body and the striations of the radially oriented ciliary muscles. Remember, the ciliary processes attach to the lens via the zonules and can change the shape of the lens to help focus light on the retina. Also, I can point out the location of the choroid, which is one part of a greater structure called the uvea. Let's quickly go back to our prior diagram, which shows the parts of the uvea very nicely. The uvea is made up of the choroid, the ciliary body, and the iris, all as one continuous structure within the eye. Basically, in this diagram, the uvea is everything pinkish in color. The choroid is a vascularized layer external to the retina, and outside of the choroid is the sclera, the most external layer. So it goes from inside to outside: retina, retinal pigmented epithelium, choroid, and sclera. These layers together give shape to the eye, provide blood supply and nutrients, and work to generate images of what we see around us.